Hello. Today I'm going to be speaking about closed hashing. What is hashing? Hashing is the storing with large key, and then we are going to change this large key into smaller keys using hash functions and hash tables. We use hashing. We use hashing in inserting and removing numbers and strings. There are two types. There are two types of three types of searching techniques. So we have hashing. Second type is linear search, which takes big O of n as time complexity, and it is not, and the array is arranged randomly. The second type is called binary search, which is time complexity is big n log n, and the list is ordered. Okay, the strategy that we're going to use is called pre-structuring, and we're going to use time and space trade-offs, which means that we're going to take more space to solve the problem solve the problem faster and easier. Here is the hashing algorithm. So here we have hash function, key space, and hash table. Hash table consists of number of indexes from 0 till 9. Key space we have different numbers of key, and hash function we have function x modulus 10. So 6 modulus 10 we have, and we are going to put the 6 in the 6th index. 5 modulus 10 we are going to put the 5 in the 5th index, and so on. But the problem happens when we have two numbers in the key space that have the same index. As you can see here, we see 4 modulus 10, which is 4, and 14 modulus 4, which is 4 also. This is called collision. Collision is probably closed hashing when we have two or more numbers having the same values. This causes collision. So what we are going to find a solution. We're going to have a solution which is called linear probing. Linear probing is in simple words, we're going to shift to the next empty index and insert the number. For example, we have here 14 went to the 5th index because it's the next empty space after the 4th index. But if you want to see it in a mathematical way, we are going to here we have an equation. As we know that x modulus the size of the index, we're going to write h of x plus f of I plus modulus size. So here we have h of 14 plus f of 0 modulus 10, which is 4. Okay, which is 4, which is index 4. So we're going to go to the next empty space, and here's its equation: h of 14 plus f of 1 modulus 10, which is 15 modulus 10, which is 5. And this is the empty space. Here is the code. The code we are going. Here we made an empty hash table, and here we used linear probing. Linear probing, again, as we said, is that we are going to insert the number into the next empty index in the hash table. And here, as he said, as we can see here, hash value plus 1 modulus self size, or the size of the hash table. And lastly, the analysis. Insertion, the best case is big O of 1, because we don't take time in searching. We see the next empty space and then we insert. Worst case is big O of n, because if all the next spaces are full, we're going to take much time to insert, which is big O of n. Search is, as usual, best case is big O of 1, the worst case is big O of n.